My name is Michael Wojcikiewicz. I'm a senior engineer at Kash Corp. We are a fintech company, a small startup run out of Toronto mostly, and also in San Francisco. I'll be talking about our experience moving to Kubernetes in the last year. So we went to production last year, about exactly a year ago, and so kind of hurdles, learning, growing pains, things like that we came across as we moved along the way. Quick intro on myself. We'll talk about some patterns we use when we move to containerization, some of our philosophies we keep in mind when we design new solutions, various problems with Kubernetes we encountered along the way, some information on how we do monitoring, and a lot of best practices and things to avoid, specifically on the Google Container Engine platform. A lot of the stuff you actually just saw the guy do, I would recommend against, and I'll get to a lot of that stuff as I get through it. We're very advanced usage, and some of the stuff will just trip you up along the way. And hopefully we'll have some time for questions and answer at the end. We'll get to that. All right, so I'm going my 20th year of professional development. My PowerPoint skills are very poor, as you can see. I don't have fancy animation, things like that. I'm a veteran of the first .com boom and bust. Used to do Perl, a lot of Perl. These days we're mostly Node.js. I spent 10 years at Morgan Stanley, a big US bank in New York, 5 years as vice president. And we worked there's a huge infrastructure working for a company. We had about 100,000 servers around the world, all different kinds of versions of OSs. Very, very interesting to work in that kind of environment. They're a Linux shop, open sourced. So I learned a lot of things for distributed design, distributed systems that I take into my everyday where I'm working now, which is at Kash Corp. So as I mentioned, we're a small startup focusing on the American market. We're about 9 engineers, actually. I recounted earlier today, and about 3 or 4 salespeople, mostly in San Francisco. So when I started at Kash about a year ago, about a year and a half ago now, they were running a traditional 3-tier design, presentation layer, business logic layer, database layer. Our deployment was on, we've been using Google Compute Engine since the beginning. So we're totally, by the way, I just want to do a quick disclaimer. So I'm going to say a couple of things that probably going to be not so nice to some Google features, but I'm doing it out of love because we love Google. We just want things to get better. I just want to highlight them. I figured this is a good forum as any to do that. So yeah, so we're running. When I started, we were running everything on VMs. So we had 2 app servers, A and B, proxy servers serving the front-end content, database server master slave configurations. It's Postgres, and we were on Compute Engine. We also have some complexity that's maybe not standard to other deployments. Since we're dealing with financial data, we have kind of a production environment that all our developers can access, and we have a secret environment that very few entitled people can do, and that's where all the sensitive data is stored. So that adds a lot of complexity as well for our Kubernetes setup, since we can't just run everything in a single cluster. Things like RBAC that came out recently, we haven't played with it, but that holds promise for us to kind of solve that problem in the long term. So our development environment is based on Docker and Docker Compose. It's pretty much exactly the way that my colleague described it earlier. We're using Docker Compose to bring up a full development stack with all our databases, all our various components, microservices, and run it that way. So we're using custom Docker images. So this is kind of a pro tip as well. If you care at all about consistency in production, definitely pin all your images, and better yet, when using images that aren't owned by yourself, do a quick fork of them and maintain them yourself. Don't rely on upstream things. People can change, people can insert rootkits, all sorts of things. So definitely take control of all your own images. So we did that for ourselves. We built our core image based on Alpine Linux. So Alpine Linux is a small distribution. I think it's about 120 megs for a fairly well-tooled distribution. And then we build Node.js on top of that, and that ships as our base image for everything, which then bundles our source code on top of that as well. With our Docker Compose setup, all the configuration options we have for our application are defined in environment variables. So that's just kind of how we started, and it seemed to be an easy way for us to change configurations on the fly. We haven't taken the Minikube dive yet. Last time I looked at it was just about a year ago, maybe a little less. There's a lot of features missing, which we needed. Things around services, things around disks, which I suppose have improved, but I don't know yet. So for the time being, we're probably going to stick with Docker Compose. I wasn't aware there's so much development on newer versions. All I got to say is we use version 2.1. It's been working very well for us for a while. And it maps, conceptually, it maps very nicely on top of Kubernetes as well. Obviously, there's not a lot of features, but when you're developing features in your application stack, you don't necessarily care about the Kubernetes-specific stuff. It's more of a DevOps type thing. So just a quick note on my distributed design philosophy, and this is heavily inspired by Apache Cassandra. The reason why I just want to bring this up is that it goes into, I keep this in mind whenever I design new solutions, and especially with Kubernetes, how to best take our legacy application and put it into Kubernetes, and what extra steps we need to do. So as I said, this is based on Apache Cassandra design philosophy, which I think is one of the model applications for a distributed design. There's no master slave, there's no single points of failure. It's a very, very well engineered application, multi-region, massively redundant. So I keep those kind of philosophies in mind when I design when I put things into Kubernetes. So specifically around no single points of failure, to be massively redundant or have lots of replicas running in itself, to be multi-region, so you can survive zone outages, which expect them to happen at least once a year. It's happened in Amazon and Google, I think, in the last year. So don't hope it doesn't. And don't assume multi-zone is enough. You definitely, no, sorry, multi-zone, you want to go multi-region. There's a concept called chaos monkey, which I'll talk a little bit about later, but not too much because I think I'm running low on time. But it's basically assuming that failures are going to happen in your application, and you're better off coding your application to be resilient for these types of failures. So chaos monkey is a thing that runs in a distributed environment and randomly brings down things to make sure that you can recover from them gracefully. Having rolling restarts, meaning less downtime when you do application upgrades. And very important as well is having a single source of configuration truth, so you don't end up juggling, configuration management database, configuration files, all these kind of places. You really want to be careful about where you store your configuration data. And that's a great way to achieve high availability. So for us, it was easy to start moving towards Kubernetes. Essentially, since we're all running everything in Docker Compose, we literally started with using the images that we had created for Docker Compose. And then we started refactoring some of the work. Our application stack is Node.js, and we had essentially a Node.js file for every project, which would contain all the configuration options for that project. So we started basically refactoring those into being able to work both as a Node.js file that we could use in our applications, but also to be able to specify these configurations in environment variables. And the way we do that is by using config maps from Kubernetes and secrets from Kubernetes. I'll talk a little bit about secret problems in a few slides, because secrets are things you want to stay secrets, but if you start putting secrets into source code control and other places, they're not secrets any longer. So first bit of work was basically separating out all the configuration data, and then we create deployments, Kubernetes deployments for each of our components, which maps the config maps and the secrets into environment variables for our application to pick up. And I'll talk a little bit about how a component we built to make that easier as well in a couple of slides. One other thing we started to realize initially, we had talked about what version of your application do you want to run in your environment? Do you want like a specific 1.1.2? Do you want something that has the commit ID in it, or do you want something else? We tried each approach for a little bit, but we ended up settling on basically using a single name tag for each environment. So you have a test environment, you have a test tag that you tag all your images. If you have a QA one, you tag it QA. If you have prod, you tag it prod. And each of those images individually then become promoted to each environment. So whenever we land, I'll talk a little bit about our build pipeline as well, but we found that was the best way to kind of separate various environments. Configuration was just to tag them with the name that they're running in. So similarly, as we have specific tags for each environment, we also have all the configuration config maps separated per environment. You had a question?
Do you use latest tag at all?
No, never. In our build pipeline, it may pull in latest versions of other images other than the one that we're building, but we never rely on latest. And that's kind of what I was talking to about before, is always pin your versions to exact versions of things that you're running. Never allow upgrades you don't expect, because eventually someone's going to upgrade it, you're not going to know that it upgraded, and you're going to spend a whole day searching for a bug that doesn't exist, right?
So when you're trying to rationalize version that you just updated in prod, do you use the comparison to the original image hash to be able to go, okay, yes, those are all the new prod tag, or?
Yeah, so part of our continuous deployment pipeline, we don't do automatic deploys to production. I'll talk a little bit in a couple of slides, so maybe I'll just hold on for that for now. Yeah, so now that we kind of did the basic refactoring of separating all the configurations, config maps, and secrets, we realized that we really needed a configuration loader for our Node.js applications to make it easy for us to take values from the environment, map them into our configuration inside Node.js, which could be a deep structure, by the way. It's not just foo equals bar. It could be multi-level structure of here's your database configuration, here's a host configuration, here's some options. Those could all be modeled as environment variables and could all be modeled as complex structures inside Node.js. So we created a configuration loader library to kind of help us to do that. We also created some tooling around to make it easy for developers when they need to add a configuration. Like if you need to add you have some new database attribute you want to add, rather than having to go into 10 different YAML files and update them and find where they are and having typos, things like that, we created some tooling around that to auto-generate our deployment YAML and our config map and secret YAML from what the application thinks it is. So the developer just goes in and adds a new item for their configuration, they run our tools, and it'll just update all the YAML for us. So when they land a code review for a feature that they're doing, we see the full context of what it is they're doing, exactly which variables are added, which ones are removed, which secrets are added, how they're mapped into the configuration, how they're mapped into the application. Everything is kind of bundled into one, or a series of dependent code reviews. No, none of it's unfortunately open source. I'll talk a little bit about why it's not in just a minute. Yeah, and so we also, our ops tooling also keeps a track of all our Google container clusters, right? So we have for each environment, we may have multiple clusters in each environment. We had just one single source of truth for that, so all our tooling can use that. When I say, restart this application in prod, or apply this configuration in test, it'll know what you're talking about just based on that. You don't have to remember cluster names and all this kind of stuff. One other thing we had to do is to really take full advantage of what Kubernetes offers in terms of rolling restarts is to implement the sigterm handler, right? So when a Kubernetes pod is shut down or basically to bring up a new version, calls sigterm on your pod, and if you don't implement that, you can just wait and kill it. But if you implement that, you can allow, if you're in the middle of a transaction or you're doing some work, to just finish that work before you actually release the handler, and then the pod shuts down. This can add some time for rolling restarts, but it makes them much less error prone. Every deployment in Kubernetes has a concept of liveness checks and health and readiness checks. So these are health checks and, hang on, am I not looking at the right thing here? Okay, sorry, I got confused. Sorry. All right, so our stack, every component that we have that's a microservice is based on a framework, and that framework has an implementation for a health check and for a liveness check. So health check would be something like, if not only is my application up and running, can it talk to the database that it's talking to? So it just does like a select now from database and returns true. Liveness check is something responding on the port. That's just, we just have a basic return the timestamp of when you're doing the call, right? So the difference here is if the pod comes under heavy load, let's say you're running 10 pods in a deployment, 10 replicas in a deployment. If 2 or 3 of them are servicing requests, they can actually remove themselves from the health check, from the ready pool of pods by reporting themselves as unhealthy, right? So what Kubernetes then will do is it'll just route the traffic to one of the other pods. We're going to talk a little bit at the very end of the talk about what the next steps towards doing that is, because what we're finding is the Kubernetes service layer that manages which pod receives which traffic when you're dealing with multiple replica deployments, it's not as responsive and as reliable as you'd like it to be, especially depending on your state of your nodes and things like that. But I'll talk a little bit about that later. So I talked about storing the configurations.
Just a quick question.
Yes.
For resource and limitation, do you use any how you find out what is the best?
Sorry, for what?
Resource and limitation.
So I have a talk on monitoring, and we basically just collect a lot of metrics, and we try to figure out what's using the most and manually balance our workloads. Right. So the reason why a lot of the things I've talked about I don't want to realize is because they were written over the span of about a month last year, and they're written mostly in Bash, which is so they're basically symbol wrappers over what Kubernetes already provides. So you have these kind of verbs: create, update, apply, replace, delete. we basically wrote like a wrapper that models each of our applications and then dependencies in a simple shell script. So for example, our main entry point for our API is defined as a single deployment that has maybe 10 replicas for the production environment, 2 or 3 services, one service to define its traffic internally in Kubernetes, and one service to define the ingress from outside of Kubernetes, and I forget what the third service is for. And then maybe one config map, one secret, and optionally a migration job. So our tooling will then say, okay, if you have all these 5 different things, which I kind of realize Helm is supposed to do, but I'll talk a little bit about Helm in a little bit. Basically, what it allows us to do is very quickly create a new, when we want to deploy a new component, we just point which YAML files we're using for that particular deployment, and all the tooling that we built around it just works with it. So for example, when you want to deploy something to production, there's always a certain order you want to do it, right? First, you want to put in your new config maps and secrets rather than after, because it requires restarting the deployment in order to pick up the new secrets, the new configuration. Then you want to apply your services. Then you want to create and delete migration jobs. So the reason I say create and delete is because migration jobs, when they run to completion, they don't remove themselves. That's to inspect the results, I think. It makes it a bit of a pain because next time you run it, you either have to create a migration job with a new name or you just delete the old one, which is what we do for now. So migration job is something like you added a new database table or you added a new database column or something like that, or you have to run some sort of series of web requests. It's just basically a job you run once rather than running, it's a deployment you run once rather than running continually. And then finally, once you've done all of that, you replace your application deployment. So you may notice I'm using a couple different verbs here, replace and apply. Replace will do complete in-place replacement of all the configuration items you're defining and removing anything that was left over from the old one. That's the difference with apply. Apply will just take the sets of what's running with the sets of the new things that you're adding, and then the end result is both of them together, which is maybe not what you want if you're replacing environment variables or replacing configuration items. You don't want to keep old data lying around. So because this order is very specific and we can use it for all our tooling, essentially all the bash stuff that I wrote just kind of does that behind the scenes, and all the developer really does when they create a new component is just a few small declarative statements saying what YAML they're using, and everything else is handled for them. We're looking at probably rewriting this stuff in Node.js as well, using the Kubernetes APIs that have since become available, but at the time that wasn't really much of an option. And the last thing it does is it validates end states. So that's after you've deployed your application, do you have the desired number of copies running that you've specified, and was there any errors or things like that? If there's any errors, we don't have automatic rollback yet, but fortunately, if Kubernetes deployments, if they fail to start, like if you put in a new version of your application, if it fails to start, it'll just Kubernetes will just eventually stop it and keep the old version still running. There's some obvious issues here if you've done configuration updates that affect the new version, but this works like 80–90% of the time for us, so that's really good really good for us.
Sorry, just want to add, because there are several interesting projects right now in Kubernetes that are not official yet, but also in an incubator. So because we don't have access to your tooling, there is a project called App Controller that allows you to create sequencing order. Like you want to first deploy secrets, configs, then database, then So App Controller is kind of replacing your bash scripts if you want to check it as well.
Yeah, I'm very curious about what's out there. Realistically, we're such a small shop and we have a lot of work we want to focus on just doing for our application features, but I'd like to take a look at a lot of the infrastructure work as well. And so I might hit you up on Slack actually for those recommendations, because unless I write them down, I'm not. And
also the Helm project as well, if you want to use Helm, you can actually implement, let's say, a check, like a job or init container. It's called init container that you can check, is my database is up? If yes, let me deploy the next application on top of it. So that's another way to implement sequencing.
Yeah, so I think I'm actually going to get this soon. With respect to, in a couple slides. Helm I found, which I started playing with about 6 months ago, and I was extremely disappointed by none of the tutorials worked. Everything it was saying was supposed to work, it didn't work, and I had no idea what to do, and I just kind of gave up. Maybe it's come a long way since then, but at the time it just wasn't an option for us. Right. So secrets. Now, obvious problem here is how do you store passwords? How do you store private key certificates in your configuration? Right now, everything I've been talking about has been in our company-wide Git repository, right? But we have a policy we don't store secrets in our Git repository. So how do we deal with that without we still get the benefit of being able to use Kubernetes secrets without a lot of overhead in managing them? So we really came up with a very simple solution. My colleague Jeff over there just kind of blurted out one day. Is Google, another feature that Google Cloud offers is this called storage buckets. And there's a command line utility that allows you to access them. So what they are is they're per project specific. You can just store whatever files you want there. You can tweak entitlements to who has access to them, which is our main things. We only wanted our developers to have access to the public-facing stuff, and only our CTO and VP of engineering to have access to our financial data secrets. So this actually allows us to do that. So what we end up storing in our code repository, instead of putting the actual contents of the YAML, we just create a special file that's essentially a symlink to the YAML. So you can see an example there. It goes to my bucket, the component, some SHA. Does this work? No. Yeah. So we created another verb for our tooling, which is very simple to do because it's all bash and everything is called edit secrets, which all it does is it grabs the file from gsutil, puts it through a base64 decode, which is how you store your secrets in Kubernetes, and then just puts the file into the user's editor, which your Emacs or VI or whatever. And then when you save it, it does the reverse procedure, puts it back, and you don't really have to think about it. That was always kind of a hassle, especially initially before we had this, was editing the secrets. You always have to do the base64 decode and encode. It's not easy to see what it is you're doing. With this method, it works. Of course, the only problem is if you're putting binary data into there, that's not going to play so nicely with your editor, but fortunately, we haven't had that problem yet. Okay, the database problem. So the Google guy said before he doesn't recommend putting databases into Kubernetes, and we've done it. Now, I'll talk a little bit about the struggles we had and things like that and limitations, but it's possible to do, and ideally, over time, we really want to have everything running in Kubernetes, not having to deal with like security updates and things like that, managing hardware, all the overhead with that. We just don't want to have to worry about it. And by the way, I just want to say we don't have any dedicated database engineers. We don't have any dedicated database administrators. We don't have any dedicated system administrators. We're a small team where everyone kind of does everything. We have some specialization, but this really allows us to not have to worry about having someone who knows how to run the database and things like that. So in an ideal world, we'd all be running Apache Cassandra, which is my favorite distributed database, but really you can insert your favorite distributed system here. But reality means that we really have to deal with what we have and where we'd like to go, possibly at the same time. So right now we have a lot of legacy, most of our code is using PostgreSQL, running in a standard kind of, used to run in a separate VM. And new code can be running in Cassandra, where we have kind of a multi-region redundant Cassandra install. So whenever we do kind of upgrades of our environment, we never have to worry about Cassandra, which is great, but we always tend to have to worry about Kubernetes a little bit. And I'll talk about those problems in a couple slides as well. So yeah, Cassandra is easy, right? It already exists in multiple data centers. It already has these kind of replication features. It means we can actually survive 2 nodes going down at the same time, but still have read and write service to the cluster. Postgres is a lot harder. Initially we had master-slave replication set up, but it still requires you to kind of do a manual action to force a failover from your master to your slave. There's probably complicated systems out there that maybe make this better, but in the end, due to the limited resources we had, that was kind of the only solution we could come up with. So once you execute the failover, essentially like a new master, you have to reroute all the traffic to the new master. So that also means you have to tell your code where the new master is. So this was, thankfully, we never actually had a situation where we had an outage related to this, but it was a problem that was just waiting to happen, and it could cause outage of several hours depending on who's available to kind of deal with it or not. There's also a hassle to have a separate infrastructure of VMs to manage, and they can't really share resources with anything else either. So we discovered this project called Stolon about 6-8 months ago. It's written in Go. It's made for Kubernetes. It basically sits around Postgres and provides a lot of high availability features that you don't have to worry about. So it utilizes the built-in streaming replications to basically allow you to define, say, okay, I want to have 1 master and 3 slaves. You just put that in your YAML, and it just manages it for you. Because it runs inside Kubernetes, hang on. lost my train of thought for a second. Okay, right. It utilizes streaming replication so I have multiple hot copies running on standby. It also allows you to quickly kind of pull the switch. You don't actually have to pull the switch yourself. The system will actually monitor the health of Postgres, and will say, okay, now this master is unhealthy. I'm going to switch over to this other master. And you connect through a component that handles sending your data to from one component from one master to the other master. It stores all its data in a distributed columns in a distributed key value store called etcd or console. So I think underneath the hood of Kubernetes, how it maintains states inside a Kubernetes cluster is also through etcd. Unfortunately, this is not made publicly available to you in your cluster, so you need to run another installation of etcd on top of your cluster to actually make this work. And I think before someone asked about if anybody was running operators in Kubernetes. We've been running the etcd operator. It's a separate project from etcd, which manages running your pods inside of etcd inside your cluster because it's a bit of a pain to run yourself. We actually found it's a bit of an anti-pattern with respect to Stolon because there's built-in backup features that you don't really necessarily want to make use of in etcd operator, so you're better off just running a daemon set or a stateful set of those, which is an approach we're going to take soon. It can do point-in-time recovery. It can actually have a standby cluster, replicate to standby cluster in a different Kubernetes cluster, which is our desirable end result, so that even if you have multi-region replication, so even if we lose an entire region in Google Cloud, we can still instantly switch over to the next region. All our services will be running in both. With Cassandra, that's not an issue because it's already distributed, but with Postgres, that kind of provides that ability. So I'm just going to kind of race through this. It's a couple of components in Stolon. Keeper manages Postgres itself. The Sentinel elects master when it's needed, and the proxy provides the entry point into Postgres itself. So your client's code talks to the proxy, and if the proxy detects a failover, it just points all your connections to the new one. Your application doesn't even have to know about it. And here I talk about the stateful set, daemon set stuff. Persistent disks, not much to say about those. They're great, especially all the dynamic allocation, but there's some issues you need to watch out for. It's really hard to track the usage of the persistent disk, like how much actually being used in a disk. And there's not really any built-in monitoring in Google Cloud for these that we could found. I'll talk a bit more about that later. Continuous integration and continuous deployment. Just want to do a quick kind of preamble for that. Testing is extremely important. If you don't have a huge unit test and integrated test suite in your application stack, you're severely lacking in confidence when you deploy new code. So because we've invested a lot of time in writing unit tests, integrated tests, and even end-to-end tests where we orchestrate a Chromium build to use our application as if a real user was using it, we can actually use this as part of our continuous deployment pipeline to be able to very faithfully and accurately deploy our code to our various environments. So all the tooling that I wrote essentially can now be leveraged using Jenkins to actually automatically deploy. So our build pipeline does a couple of things when anyone lands a new commit. First, it builds a new candidate image with a specific commit SHA as a tag. It runs through our unit and integrated test suite as the developer should have done before they submitted. It runs the end test locally before it actually puts that image into our new environment, and then it deploys to our test environment using the tooling I had referenced before, and it runs another end-to-end test. If all that succeeds, it reports the results back to Slack, and it gives the developer a command that they can run by themselves to finish the deployment to production. The reason we don't do the automated production deployment is we just like to be a little bit extra safe. We like the developer to be aware of when that actually happens. But it allows us to very rapidly develop features and push them out. And, we have several deployments of all our components daily to production because of this. Monitoring. I'm running low on time, so I'm going to try and get through on these. We use Prometheus. It's been mentioned a couple times before. It's really great. It hooks into a lot of native Kubernetes metrics, and you can federate them from multiple environments into a single Prometheus environment, and then you can also create alerts depending on those. So if you say, I have a certain number of 500 codes in my application, you can create an alert, all those kinds of things, right? It's also a lot more complex than that. You can create standard deviations of traffic and all that. And we use PagerDuty for our incident management. So anything that generates an alert inside Prometheus ends up in PagerDuty, and whoever's on PagerDuty that week takes the incident. As great as Prometheus is, it does lack a couple of things. It only collects information that's available to it. So there's a lot of information that we want to look at that Kubernetes doesn't really expose. Important things are basically events in Kubernetes. So whenever a pod restarts, a pod errors out, a pod has an eviction due to low resources. If a node has an event, say like a node fills up on disk or a node has excessive inodes or all these kind of things. These are things that happen inside Kubernetes, but you don't have visibility to you don't have the visibility natively. I mentioned before the disk usage of persistent volume claims. So if you have a stateful set that has a database that has a persistent volume claim for the database, you really want to know how much space you're using on that database claim. And one thing that Prometheus doesn't provide natively either is inode monitoring on your actual Kubernetes nodes. So this is a consistent problem we've had. We deploy a lot of images very frequent to our environment. About once a month, one of our nodes has some excess inode thing on it that we have to go in and run some Docker commands to clear out. But like, we spend a lot of time trying to figure out what the hell went wrong before we realized that was an issue. So what we ended up doing is we wrote some small agents that actually do a lot of these tasks by themselves. They're like 20, 30 line Node.js scripts. Basically just talk to the Kubernetes API using watch. Like, I don't know if you guys have run kubectl with -w. You can actually watch things as they happen rather than just getting a snapshot. So this way, we actually have agents that constantly watch the state of pods, the state of nodes, the size of disks, and they report those as metrics into Prometheus. So we have a dashboard that says, you know, when we can see like a high spike in some error codes combined with a lot of state changes in one of our components, we know that those two events are correlated because if someone deployed something, odds are some things are going to start going wrong, right? So you can kind of, it helps you give you a lot more intelligence into how you're monitoring, how you're operating your cluster that way. One other component we developed was the disk snapshotter. So since Stolon runs exclusively inside Postgres or inside Kubernetes, and we use persistent disk for that, we also want to make sure we keep copies of those persistent disks around. So we have a snapshot that runs daily, keeps 30 days worth in production, I think keeps 7 days in test. It allows us to, you know, if we discover some horrible disaster went wrong, we need to recover to a point in time, we have snapshots for that. There's a term called exporter in Kubernetes world, where if an exporter is basically something that gives you metrics somewhere, generally to Prometheus. So people have written some exporters out there to expose the node level metrics. So that's what the node exporter is. That's a very good thing to install on your nodes. It installs as a daemon set. And the Postgres exporter, if you have Postgres databases, will look at Postgres engine metrics and report those into Prometheus as well. I forget what we end up using for JVM metrics, but we also export Cassandra metrics as well. You definitely want to keep if you're using Cassandra in production, you want to keep there's a lot of key metrics you want to keep an eye on. Okay, so a lot of the value I was going to give in this presentation was actually a lot of the best practices and things we've learned over the last year or so. So generally, I want to say these are just my experiences. They're not written in gold or set in stone anywhere, but this has been what has worked for us since the beginning. So avoid bleeding edge, right? So you had the question about who's running 1.7, and I'm glad to see there aren't many more people because you're out of your mind if you're running 1.7 in production now, or you're very risky. Generally, I found when a new version comes out, we generally don't even start looking at it in testing until it's hit about version 0.4. If you look at change logs for each version and known issues and things like that, you can see there's a lot of stuff that gets ironed out. Essentially, if you sign up for a release when 0.0.1 comes out, you're the beta tester, right? And you don't want to do that in production. Make sure that when you do try a new version, before it goes to production, make sure you try it fully baked in your development environment or non-production environment. This should probably take a couple of weeks, ideally, but at least a week running in non-production. You also want to make sure you retest all your rolling upgrade procedures for production. So for example, we went from 1.5 to 1.6 recently, and the pod affinity stuff that I had asked about before, it used to be an annotation in your YAML with a little bit of JSON in a string, and it changed into a fully declarative YAML keywords, but it wasn't at all. You could do the same things, but you had to describe it very differently, right? So we ended up having to, first of all, we discovered this the hard way. Then all of a sudden, when we upgraded, nothing is running where it's supposed to be running. We discovered, okay, this feature had completely changed, but it also made necessary that when we actually put 1.6 in production, we had to change our normal deployment procedure because we had to deal with this in-between state of being at 1.5, 1.6 at the same time, and having two different annotations, two different and declarations for the same thing that would work differently depending on which node it runs on. Somebody asked about database migration. Our general approach to that is we don't try to overcomplicate it. We have one database at most per component. We use a module for Node called db migrate, which allows you to ship along with your feature work basically a set of statements that allow you to also patch your database, right? So there's a statements for actually putting in the column that you're adding and there's statements for removing in case you have to roll back. This has worked really well for us as long as we take the approach where if we need to add like a feature that requires a new column, we don't ever rename an existing column, right? The reason for this is if you have a new deployment that relies on the column working this way and you have the old version replying the column working this way, if something goes wrong, they get stuck, you get kind of in between scenario. So you always want to make sure as often as you can, if you need to make modifications, do adds, deprecations, and removes. Don't ever just change. So this could mean that by the time, if you want to add a column and remove a column, it could take over 3 releases to do it, but it's a much safer way to do it. As well, don't ever run in a single cluster. I've seen some people talk about namespace separation for prod and QA and things like that. Very, very bad idea, especially since when you upgrade a cluster, you don't know what's going to happen. There's many features that get added or removed. I talk about the node affinity that you're not going to know until you've actually put it in place. So don't keep your prod and non-prod data on a single cluster. I hope I didn't really have to say that, but I just want to be sure. Yeah, so here's some criticisms and some best practices I've learned along the way, and a lot of them are very specific to Google Container Engine. So there's a feature called node labels, which allows you to designate a specific node in your cluster to contain certain workloads. So this is kind of what I was talking about with node affinity before. Problem with this is you can create a node label, but you can put it on a node, but next time you upgrade that cluster and that node, logically, to you, that node will have the same name, so it'll be called, foo cluster XYZ. After you upgrade it, it'll still be called foo cluster XYZ, but your shit will be gone. There will be no node labels, there'll be no nothing. And when we filed a request with Google support for this, and they came back to us saying, well, this is a feature, not a bug. And I'm like, don't care. It just doesn't work, and it makes it useless. Essentially, was it behind the hood, behind the scenes, the VM gets decommissioned and replaced with another VM that has the same one. So it's not the same in that sense, but it is logically the same because it has the same name. So don't do that until they fix it. Don't use alpha features if you can avoid. Definitely not in production. Sometimes you'll be tempted to, but there's some costs associated with that. One is you have to designate your cluster as being alpha, which has to be renewed every 30 days. But really, oftentimes this would happen with the node affinity I was talking about. They can change significantly one time they come out of alpha or even beta. You just got to be very, very wary of that. IP persistence is another problem that's very Google Container Engine specific. If for whatever reason you use node port services to talk between 2 clusters or whatever your use case is, you want to know what the node port IP is. The IP is generally the external IP of your VM. So you can reserve your IP address, you can assign it to the VM, but when you upgrade that VM to the next version of Kubernetes, Kubernetes just assigns it a new IP, and better yet, you're not allowed to put the old IP back until it's done upgrading all your nodes. So if you're upgrading like 4-node cluster, 8-node cluster, it could take half an hour, 45 minutes. Those 45 minutes, you can't assign IPs back to that cluster. So huge pain in the ass. And then, of course, if you have to assign them back internally, so there's external IPs for that. Internally, it just gives you a new internal IP. That you can't even assign either. So you very often after you execute an upgrade procedure, you have to also go and upgrade your config maps again afterwards. So in order for us, our lesson learned best practices upgrade procedure is generally this now. Since the master gets upgraded automatically, which by the way I'd love to be able to opt out of because I don't trust to have automatic upgrades, it doesn't automatically upgrade your node pools. I would also say don't ever put up the automatic update of your node pools either because if you don't, you're just going to be spending days hunting things that broke for even no apparent reason until you realize it was upgraded without your knowledge. But our approach then is to basically, when we upgrade, we're anticipating going from 1.6 to 1.7. our master is probably already 1.7, so rather than doing a rolling upgrade on our existing pool, we're going to create another pool with the exact same specs running the newer version, change our pod affinities to point to the new version, and manually fail over each component to the new version, and then decommission the old node pool. This should be something that the tooling could do by itself, but it doesn't, and for all the reasons I've already talked about. Don't trust managed infrastructure. So a lot of what this guy's talking about is all great and good if you're running in a very kind of simple application and simple structure, but it doesn't really translate well to reality. So really, always validate and monitor what you think is happening. Watch out for little quirks, like I'm talking about the node pools, causing the IPs to become unavailable for the duration of the upgrade. There's something else I wanted to add here. Oh yeah. Talk about it in a second. One of the examples uses Redis in Kubernetes. We found Redis in Kubernetes is extremely unstable, especially like any kind of serious prod deployment. We're about 50% chance whether we have an outage with Redis when we do an upgrade or not. This is something that may have been fixed in version 5, which I think came out recently, but we're not sure. So just be wary of that. I talked about Helm, had tried it out. Might give it another try now if everyone's talking about it. Ingress at Google Cloud, this is another very Google Container Engine specific thing. It can be difficult as well. There's some built-in limitations to how Google will model your Kubernetes cluster and deployment versus what it actually exists as in Google Cloud terminology. So the guy showed, when you create a 4-node cluster, there's 4 VMs that are automatically created associated with that. Those VMs are also created in what's called an instance group. So every time, like for example, you create a service in Kubernetes that's fronted by something, Google will create a load balancer and put that instance group in that load balancer, right? That's great for when Google manages that. For another reason, one reason or the other, we couldn't use the built-in Kubernetes load balancing features, so we had to create a separate global load balancer in Google Cloud. And then we would assign our instance group representing our applications in Kubernetes to it. But what we ended up finding was if we wanted to have, say, for example, multi-region deployments where we'd have one Kubernetes clusters and group in one region, another Kubernetes cluster and group in another region, we couldn't put both groups on the same load balancer. Even though it should be able to, you can only have one group associated with it. And inversely, these are just little things that you expect to work, but like there's no reason why it doesn't work, and there's no explanation given. They don't support it yet. I found that happens a lot with Google stuff. It's like it works for them, and they don't have a concept of what your use case is, so they don't code for it. Yeah. VPN tunnels at Google can also be very difficult. So recently, I think it's about 4 months ago now, we had a 15-minute VPN outage. So I talked about our cluster supporting having our developer public one and our financial data private cluster. They're connected with a VPN tunnel. So we had a 15-minute outage recently, which, if you can imagine you're a financial tech company, someone like PayPal taking payments. If you can't do payments for 15 minutes, it's a pretty big outage. It's a lot of money involved. There was no notification for Google this was happening. This wasn't put up on the incidents board. This wasn't like even reported. So we filed a request, and the support person came back to us and said, oh yeah, this was down. And since we're still meeting our 99.7% SLA, we didn't have to report it. That's 30 minutes in a week that your shit can be down, and they don't have to tell you. That's a little bit unacceptable, if you ask me. We also, because we suspected this was the root cause behind a couple of recent failures that we had, we requested logs of previous failures, but it was just ignored, and we just gave up. So we weren't ever able to satisfactorily find a root cause for those. So the lesson to that is always monitor your managed infrastructure and try to have multiple redundant versions of the same type of infrastructure. So in this case, the Google support guy came back to us and said, well, you should have had multiple VPN tunnels, because then you would have been able to survive the one going down. I'm like, well, we didn't even notice. It happened during a maintenance window, which is also not advertised. So it's like, how could we possibly have known? Node failures. So if the actual VM representing your Kubernetes node can go down, this can actually have in our experience, had a lot of impact on the Kubernetes service calls themselves. So we had an incident a couple weeks ago where the node was in a bad state. It wasn't rebooting. It was never coming out of a good state. And nothing that was running on it was being rescheduled to run on another node. So what ended up happening was Kubernetes kept sending traffic to the bad node, and like 1 in 4 calls would fail, and we couldn't figure out why until we looked at the node. And that also was the genesis of a lot of those extra agents I was talking about to monitor the health of the nodes, because we wasted a lot of time looking for things that couldn't have been the problem if we just had the intelligence to know what was. And then I would say it's hard to justify paying for Google support, but we still do. So we gripe a lot about Google support. We send a lot of cases. We try to be very interact with them on a helpful level to try and solve them. But up until recently, there's really not a lot they could do. They don't have access to your projects. They don't have access to get into your data. And everything they could do would have like a sometimes 24-hour turnaround before they got back to you. And you're sitting there with a production outage. It's not really workable, right? I would say that recently they've come up with a way for them to entitle their support specialists to be able to go into your environment and do their own investigation. So you're not waiting on people collecting logs or doing things like that. They can actually do it themselves, which I think would have helped a lot in certain situations recently. Okay, the future. So this is what we're planning for about the next year or so. Hopefully we can get a lot of this in. So if you're using Kubernetes and you haven't heard about Linkerd, do yourself a favor, write it down and Google it tonight. It is a great piece of software that runs as a daemon set on every node. Essentially a transparent proxy that provides service discovery, routing, failure handling, retries, all the things that Kubernetes service itself should do well. Linkerd does even better. It also enables very easy deployments of canaries. So canary deployment is like you want to try a new version, but you don't want to fully roll it out. You kind of want to send some amount of traffic to it. Linkerd has a native way of used to say, send 1/4 of all traffic or 1/10 of all traffic to my canary deployment. You validate that it works, and then you kind of roll it out to the entire environment. We also provide end-to-end metrics and request tracing. So you do have to modify your application to take certain headers, pass them downstream through your application stack. But if you do that work, you can literally get a view. There's a tool, I think it's called Zipkin, that allows you to see the life cycle of your request. So if you go through 10 different services, external service calls, things like that, you see every step along the way, how long each step took, what the success rate was, when it had to fail, do something else. It's all like easily lined up. And it's a great way to do performance engineering and reliability engineering. It also has Prometheus exporting, so everything that you can see there you get for free in Prometheus if you use it yourself. We definitely want to move to multi-region setup. Right now we're not. We're just in one region, and this is to survive zone outages. I also consider going to multi-cloud. I considered using Amazon as our backup cloud or something like that. It's probably way further down the line. But in case you're wondering, like, look it up. There's been full zone outages in the last year. And if you're okay with being down for 4 or 5 hours, then okay, but we're not. We really need to be able to survive those kinds of situations. I talked about Chaos Monkey before, about it's not adding instability, but it's basically testing your reliability of your application by randomly killing things. Another thing we're working on currently as well is continuous grind and performance engineering. So continuous grind is kind of a term I came up with where we have a cluster that's spec'd similarly to our production cluster, but it's spec'd to run 10 times or more the amount of volume that we're expecting normally. Ideally, what we'd like to do is make this part of our deployment pipeline, meaning that when you land a feature, it'll go through all the normal steps, and then at the end, it'll get to the performance pipeline. It'll get put in a performance cluster, and then all the scenarios that we expect this feature to perform as will then be run and come back with some sort of report saying that either you ran it with this standard deviation of normal performance, or it failed in this many times, what have you. The idea is that we know that right away before everything goes to production, we're not going to have a negative performance impact as well. And eventually, we'd like to put absolutely everything in Kubernetes as well. So we have Cassandra is the only thing running outside of it now, but with the new stateful set stuff that the Google guy was talking about, that might be a possibility in 1.7. I have some references to the things I talked about, and a nice InspireRobot quote. If you're the only one who understands the universe, there's no need for the universe. That's why I'm here today. Okay.
Wow. Amazing.
Thanks.
Round of applause. I just feel very bad that this was the last talk, because initially it's supposed to be the first one, but because we had to, change something on fly, but I think it's by far one of the best talks I ever heard in Kubernetes Meetup. So round of applause. So for those who couldn't make up, we have recordings, so you can watch it again at home. We're gonna share the slides in the Kubernetes Slack channel. What else? This just shows GKE is one of the best places to run by far, but still there is a lot of problems that you may encounter, and Kubernetes is evolving, and like talks like that, I think, provide the good feedback, what you have to like monitor everything still and do logging, and actually have feedback about Linkerd. So this is project kind of was very popular, but right now, right now there's another project called Istio, which is going to be very similar in the feature, but it's going to be much more lightweight because Linkerd is written in Java, so it's like you're running heavy load.
Let's not start a religious war.
Yeah. So Istio is basically coming from the company called Lyft, the one that's driving, kind of Uber company. So they used very lightweight proxy. And right now, Google, IBM, Red Hat, and like another companies that involved together in this project. So it's going to be alternative for Linkerd. So if you guys want to assess, that's going to be a good option. Yeah, I think we're good. If you guys have questions, I mean, I know everybody wants to go home. It's past 9, but like, I saw people were super interested in this talk. So if you have a question.
Are you using Stackdriver for any of your monitoring? And have you had any issues with the Google load balancers or any of the metrics?
Yeah. Okay, Stackdriver. We're using the logging feature of that, so all our application standard out logs are all consumed by that Stackdriver logging interface like I was showing. So it's very easy to go in and trace issues as well because all our components are just listed there. Load balancers, yeah. We have several cases, and I think they're all closed, but like with Google about so the problem with the load balancers, they don't give you access to logs. You can't really see what's going on since they're all managed. And this can cause huge issues if you think the problem with the load balancer, but you can't prove it to your support guy that it is. What we ended up having to do in the past is we ended up just because we could have no other solution, we ended up just creating new load balancers in a different way, and that somehow magically solved the problem without ever explaining why.
All right, I think we're good. So yeah, I hope Mike will be also on our Kubernetes GKE Slack channel.
Yep, yeah, I'm there.
So if you guys, running GKE in production, we have Patrick just said that he's going to be like helping us to answer questions, and Michael as well, right? Hopefully we can together help people to run Kubernetes.